Good morning to everyone. My name is Konstantinia Papadimitriou. I'm a chemist and I have a PhD in polymer science and technology. The last 6 years I work in Admiris company as a project manager, and I specialize in sourcing and mapping of primary and secondary raw materials. So in this presentation you will see a global mapping of the manganese sources with emphasis on European low-grade manganese ores, including which have high critical raw material content, including rare earth elements, which are of high importance for HAlMan project. So we will start the presentation by mentioning very briefly, because Zafar already mentioned, an introduction to manganese and its application, the classification of manganese ores, and then you will see the manganese deposits worldwide, along with its production and reserves. And the major manganese deposits in the world, some chemical data about these sources regarding the ore grades and the rare earth element content. And finally, in Europe, you will see the production, the major manganese deposits, along also with some chemical data there. And also, since important sources of manganese are the manganese tailings from ore beneficiation processes, you will see a brief slide about the content of manganese in them. And we will conclude with the manganese resources in the ocean in the form of manganese nodules, which are very important sources due to their very, very high manganese content they contain. We will end with the conclusions. So very briefly, manganese is a transition silvery brittle and hard metal, which can be found in minerals in combination with iron. It was first isolated in 70s. It is important because of its desulfurizing, deoxidizing, and alloying properties, and its principal use is in steel making as an alloying addition in steel. Actually, steel cannot be produced without manganese, since manganese has not any known substitutes in the overall conversion of iron ore to steel. Steel and cast iron production together are the largest markets of manganese. However, it can be also alloyed with non-ferrous metals such as aluminium and copper. Some non-metallurgical applications include its use in the battery industry to produce battery cathodes. Also, it can be used in electronics, in fertilizers and animal feed, for water treatment chemicals and other chemicals, which are mainly those used as colorants. For example, automobile undercoat paints, bricks, fritz, glass, etc. Sorry for that. So the genetic types of manganese ores are mainly sedimentary, volcanic sedimentary, hydrothermal sedimentary, and metamorphic and weathering crust. We can classify manganese ores as high-grade manganese ores, which contain manganese content more than 44% and are mainly located in South Africa, Australia, Brazil, and Gabon. To medium-grade manganese ores with manganese content from 30 to 44%, mainly and are present mainly in India, Kazakhstan, and Mexico. And low-grade manganese ores, which have less than 30% of manganese and are located mainly in Ukraine, Ghana, but also in other areas. It is found in more than 100 minerals in the form of sulfides, oxide, carbonates, and you can see a list of important manganese-bearing minerals here. Zafar mentioned them. I will not go into details. And here we can see a world map which shows the location, the relative size and type of the major manganese deposits in the world, but also the areas of greatest potential for seabed mining of ferromanganese nodules, which can be seen. Let me have it like this. Which can be seen by these colored outlines here. In the table, you see the identified resources estimated for the major land-based manganese deposits. You can see the country, the deposit, the type of the deposit, and the resources. Without any question, South Africa has the largest manganese reserves worldwide by far, followed by Ukraine, Australia, Brazil, China, etc. In 2023, the total global reserves of manganese were estimated at around 1.9 billion tons. And if you notice here, the reserves of manganese from 2010 to 2023, we're talking about a more than threefold increase compared to 2010. However, the global resources in traditional land-based deposits are much higher at about 17 billion tons. And the annual global consumption is around 60 million tons. And from the data mentioned before, you can understand that current reserves are adequate to meet global demand for several decades. Here is the table taken from USGS for the manganese world production and reserves. You can see the most important countries and the mine production from 2022 to 2023, along with the reserves. African countries account for around 65% of the global mine manganese production, and especially South Africa accounts for 70% of the world's manganese resources. Therefore, the major producing countries are South Africa, of course, followed by Australia, China, Brazil, Gabon, and Ghana. In green, you can see the major European countries, which are Georgia and Ukraine. And after the production of the ore, it is smelted to make manganese alloys, with China being by far the biggest producer. This is a summary table, summary comparative table of significant manganese deposits in Africa. You can see a lot of data there. I will not go into detail, just to say that currently practically all of the production of manganese ore in Africa comes from only two of the deposit types, and it is mined in 3 districts: in the Kalahari manganese field in South Africa, in the Vatsivili, Gabon, and the beryllium deposits of West Africa in Ghana. Since of our interest is also the rare earth element content in these ores, we searched about this, and in the cases that it was available, we found out that in the majority of these deposits, the rare earth element content is low. In this map, you can see the Australian manganese deposits and operating mines. In Australia, there are 3 operating mines: the Groote Eylandt, the Bootu Creek, and the Goody Goody. And in the table, you can see the Australia show reserves of manganese production and potential reserve life from 2002 to 2019, where the ore reserves are 91 million tons, the production 7.5, and the reserve lives around 12 years. The Gemco manganese mine at Groote Eylandt produces more than 15% of the global production. It can be seen here. And we're talking about a high grade manganese ore with a manganese oxide content of around 62% and very high, I would say, rare earth element content with a total value of 2,060 parts per million. Another mine there, important mine, the Goody Goody mine, it is also a high grade manganese ore deposit, so with a manganese oxide content of 56% and a moderate, I would say, moderate total rare earth element content of 73 parts per million. China is ranked 5th in the world in terms of total manganese reserves. In the table here, you can see the characteristics of important sedimentary manganese deposits, mainly the major ore minerals that consist these deposits. And here is the chemical composition of major manganese deposits in China. There are low to high grade manganese ores, as we can see here, and in most cases, and in the case, of course, that it was available, the rare earth element content, we found that it is low, with an exception of this final deposit here, the Guiche deposit, which has around 150 parts per million of rare earth element content. Also, since Brazil is also a major producer, you can see here the chemical composition of major manganese deposits in Brazil, which are medium to high grade manganese ores, with, in the case of the last deposits here, a rare earth element content of 133 parts per million. Now, some data about Europe. It is important to mention that the economic importance of manganese was very high always in the European Union. Manganese was a strategic raw material because of its use in steel making and batteries, and became critical in 2023 due to supply risk which was caused by the lower domestic supply, by the lower domestic production dropping from 32 to 10 tons because the production in Bulgaria and Hungary stopped, which in turn increased the imports from South Africa and Gabon. In the table, you can see the manganese ore European production in tons. As I told you, in Bulgaria and Hungary, the production is stopped. We can see the production from 2015 to 2022. It is produced in Georgia, Romania, Turkey, and Ukraine, and the European production is estimated at around 2 million tons per year. And if we are talking about European Union, only Romania is a producer with around 30 kilotons per year. Also, in the last column of the table, you can see the companies that exploit these deposits. The most important, let's say, manganese deposits in Europe are located around Black Sea and form an arc around the north side of the Black Sea, stretching from Turkey to through Bulgaria, Ukraine, Russia, and Georgia, and finally into Kazakhstan. The collective reserves of this area are in the order of 600 million tons, which make this region the world's second largest repository of manganese, after, of course, the supergiant Kalahari manganese field of South Africa. Here is a summary table of the major manganese deposits around the Black Sea. We can see in this table a lot of data, like the age of the protor, the country, the size, the host rock, the chemistry, etc. And in the case that was available, the rare earth element content, and we can see that we have low to high grade manganese ores also in these areas. And in the cases that was available, the rare earth element content in Georgia here is high, along with the deposits here in Ukraine, meaning that it is very important for HAlMan project for valorization. Some other manganese deposits in Europe are located in Hungary, Romania, Sweden, Greece, and Italy. They are low to medium grade manganese ores, and in the case here you can see of Hungary, we have very high rare earth element content, also in Romania, and these are resources that we will try to exploit in HAlMan project. Another important source are the manganese tailings from ore beneficiation processes. Due to their high manganese content, as you can see here in the table, which shows manganese content in manganese tailings globally in Brazil, Australia, China, and Greece, with an exception here in Brazil, in the Azul deposit. The other tailings, you can see that have very high manganese content, more than 20% in all cases. However, the volumes and the rare earth element content was not available. We're still searching. And the last chapter of this presentation are the manganese resources in the ocean in the form of manganese nodules. The total amount of manganese nodules is estimated to be over 3 trillion tons. The ferromanganese nodules typically occur at water depths of 4,000 to 6,500 meters. You can see here the global distribution of manganese nodules in the oceans. Actually, they are present in all oceans, but only 4 regions, and in 4 regions, the density of nodules is great enough for industrial exploitation, and these regions are seen here in the map. They are the North Central Pacific Ocean, the Peru Basin in Southeast Pacific, and the center of the North Indian Ocean. This is the world's largest manganese nodule region, with a total mass of manganese nodules to be around 21 billion tons. In this zone here, which has the largest content of manganese, it's around 15 to 75 kilograms per square meter, but also the other areas here have high manganese content. This table shows the metal content of manganese nodule occurrences in million tons in the Clarion-Clipperton zone you saw here, which has the highest amount of manganese. And for comparison reasons, you can see also the global reserves and resources on land, and meaning here in this column both economically recoverable and sub-economic reserves, And here the global reserves on land, which are economically recoverable reserves today. It is obvious that the occurrence in this zone alone holds around 10 times more manganese than the economically mineable deposits on land today. But also we can notice high contents of nickel here, of copper, etc. Here you see the chemical components of manganese nodules from different marine regions, the most important, as previously mentioned. And although the conditions for the formation are the same in all 4 of the major regions, the metal contents vary from place to place. The highest manganese content is here in the manganese nodules of the Peru basin. It's around 34%. And we can notice in all cases very high rare earth element content, including yttrium. The mineral composition of ferromanganese crusts and hydrogenetic nodules consists mainly of poorly crystalline iron bearing vernadite, but also a variety of detrital minerals compose a minor part of the crusts, which are mainly quartz and feldspar. However, in spite of this wonderful data here regarding the manganese and the rare earth element content, the manganese nodule mining at an industrial scale is presently not possible due to a lot of reasons, mainly due to lack of equipment, and you need to have special permits in order to mine in these areas, which is a very complicated procedure. To conclude, manganese is a critical element for crucial industrial and economic sectors, mainly in steel production and renewable energy technologies. South Africa has the largest manganese reserves worldwide, but they have relatively, in most cases, low rare earth element content. Manganese is classified as a strategic raw material in the EU because it supports core industries like steel and is indispensable for the green transition and decarbonization. However, it presents supply chain risks, and Europe relies on imports. So strengthening European Union's access to manganese is essential for its industrial, economic, and environmental resilience. And we have low-grade manganese ores in Europe, in many countries, mainly in Hungary, Romania, Ukraine, Sweden, Greece, with some of them containing high rare earth element content. Also, there are manganese tailings from more beneficiation processes with high manganese content, which can be exploited in the project. And we can conclude in the final analysis that Europe has access to low-grade manganese ores with high rare earth element content and can be utilized in HAlMan process, contributing in this way to an increased manganese production, and simultaneously reducing its reliance on imports, mainly from South Africa and Gabon. Thank you very much for your attention.